right. Good morning, students. Can y'all hear me okay?
Yes.
All right, good. I'm trying with different things here, and I don't know. It's just not good the way this office is set up. As long as y'all can hear me and I can hear y'all, you folks, I'm all right. Because I'd like to have the. You can't see my picture on my Chromebook because it's against the window. So anyway, we are in our review mode, and we had pretty much gone through that whole practice test, and so if there's any questions, I did that was that one problem that I kind of was trying to rush through, and what it amounted to is I went ahead and worked it out. It's just that it it ends up being kind of long, and so that's why I said I was gonna work it. I wanted to try to finish that review, but anyway, so has anybody got any questions before we move on to we're going to do a little bit more prep today for the review. I got a little assignment I want you folks to do to get ready. And then at the end, I'll get that application. There was an application that we did pretty much just like it in class, but like I said, is this one. Um, what you just got to do is you just got to find you, you got to find vertex is all it is to get your width. And like I said, on that one it was kind of messy, and so it was going to take a little bit of time to figure it out. So here's where we're at in terms of we're just going to call it midterm exam. It's the third test, but it's the midterm exam. So it's open now, and it'll be open through tomorrow because on Thursday we'll be starting over new stuff. So we want to get these two sections under our belt, then do chapter four, the rest of chapter three, and then have our second test. It looks like on the 11th, we're still having this conference that I was concerned about if they were going to still have it. All right, so let me just put this assignment that I want to have you do. And while y'all doing it, I'll get things ready. Okay, can y'all see that? So what you can do is you
Yes.
can on paper, and you can um, use your phone to just show me. I'm not going to grade them. for being right, but I will give you feedback in the Canvas on them. It's going to be basically just participation. So, okay, I'm going to put it in a column there. Give me a second. I'm going to do another little Chromebook. So I have to take that off of there. If you have any questions, just shoot. I mean, if you want to discuss the problem or what, just bring it up. I'm going to make a little column there now in the grade book in Canvas. If there's any questions, I'm going to give you what you need. I just want to give you get your blood on exam stuff. All right, and then I got the little column set up. You should be able to go into assignments. Uh, Now let's see if I can switch over to being a student to show you what it looks like. It's basically just like the upload photo ID thing. Let's see, under assignments. Well, where's it at? Am I in the wrong? No, I'm in the right class. Okay, now we should see it. So right there, that midterm prep. So what you can do, like I said, is just go through your the practice thing and just pick out any five you want, work them out, and then that's what you're going to send to me. And when we're done, like I said, it was it 18. I'll go through this one because I didn't get a chance to finish that one. Okay.
Yeah, I struggled with that one. I took the midterm yesterday. I got it
Well, you
right, but
don't have to include that one, but I am going to go over it again. I'll try to make it a little bit clearer too.
I ended up getting the right answer, but I still not really sure. I think I just got lucky.
Well, basically, what you're doing is, all right, okay, can you see the little picture there?
Yeah.
All right, they're setting it up for you. So remember, x is the width, and then the 650 minus 2x is the length. So you're going to multiply those two things, and that's going to give you a quadratic equation. And then
Uh,
all you do is just put it in the standard form. It'll be something like negative 2x squared minus 650x. And then what you do is you use negative b over 2a to find your x value of your vertex. And then once you find that width, you put that, I'm sorry, once you put that's x, the width, you put it in there and find out what the length is. And then what you do is you put the ones, whatever that length is, in back into the equation, and that gives you the area you would have.
yeah. So it ended up being like a 1/4 of the
Yeah,
constant
you're
that they
right. And
gave you.
that's kind of why I kind of got a little bit frustrated with it because this is going to take longer than I thought. So
Yeah.
that's the issue.
But yeah, so like I did the practice problem a couple times, like, they change up the variables. And then I took the midterm test yesterday. And every
Okay.
single time I figured out that it ended up just being 1/4 of the constant variable was the answer to what X was. And then from there, you can kind of figure out the rest pretty easily.
What quarter of the constant variable?
Yeah.
I'm not 100% sure what you mean by that, but
So like the 650 that they have there.
oh, okay. Are you talking about that's what you call the B? The
Okay, the
B.
B. Okay.
Yeah, because it doesn't have a constant. Constant would be just the number hanging off the end. And
Right.
if you when you multiply by x, it's 650x. Yeah, because what it is, it's negative b over 2a. So you multiply just basically just divide 2 into 650.
Right.
Yeah. Okay.
Okay.
Yeah. On this one, it just may not always be exactly. But probably on this, because it's an algorithmic thing, it probably will work that way. But if you found a pattern, all the better.
Yeah, I mean, that's just why I was curious about clarification, because I feel like I just figured out how this, one problem they gave us in the book works. They might change up the numbers in it, but like every single time it ended up being the same. And I was curious that if, you know, there were other situations where that wouldn't necessarily work out.
Yeah. But if you found one, if for this, then it's good. But just be cautious about it. Some people are better picking out patterns than others. But you know, well, it's good that you figured it out. Well, like I said, is I mean, this is just to prepare you. If you want to do it, go ahead and do it and put it in there. It's just going to be a small part of the homework grade, so it's not a everything right kind of thing. It's just I want to get y'all working, and then right about 10 o'clock, like I said, I'll go through that when I was just showing you. All right, so y'all seeing that? That's it. I just don't know what is wrong with the Wi-Fi here at school. Because I try to have my little Chromebook up here set up so I can see what you folks are seeing, and it's like it's showing me something different than I thought I was showing you. Well, probably when I get into the other building, it'll be a bit later, but I still can't. They don't have the computers over there yet. Okay, there it is. So you are seeing it. I don't know. I'm just going crazy from all this stuff. So anybody that just came in, look at that little woman on the board. But if you just feel free to ask because I'm not ignoring you. I'm just the little bit of I can get uh, uh, All right, y'all doing okay?
Yep.
And then, as I said, once we get about 15 minutes left, I want to finish this one. This is the one. It's a little bit long, and I didn't finish it because I wanted to try to get that whole review through, and I just kind of glossed over this one. But the good thing about it is they already give you the setup here on it that um, makes it pretty easy because you just find the area by multiplying these two, and then that's the function you're gonna what's called maximize it, because when you look at it, you'll find that the coefficient in front of the x squared is negative, which means it's going down like half of an arch. So that's the top point, the vertex, means that it's a maximum when it's up when it's like that on its feet. And then just as I said, is after you finish this, giving you kind of this day as a prep, we got two sections, and then we'll have another test. And this is really, not that bad. The 3.4. So, because I go over that with my 130 students, and it's really kind of interesting. It's really just using what you learn in 3.3 here, and it's almost in a way it's a little bit can be a bit fun because it looks like it's long and daunting, but you can use things that you've learned so far to take. I'll be right back. If you have any questions, put it in the chat. All right, I'm still in there, out there.
Still here.
All right, so how you doing? Is anybody having any questions?
Could we go over the second problem in the test, the practice?
Sure. Let me finish this right here real quick.
Okay.
All right, so then let me just finish. All right, so basically, I'll just do this real quick here. So that's your length. I mean your width, and then there's your length. And then the area is equal to 52,812.5. I should have just typed that in. So that's the area. And you can multiply those and find it, or you can take 162.5 and put it back in there. Either one will give it to you. All right, let's see. Number two. All right, so okay, so what it is, all right, you want to get everything on the same side. So I'm going to subtract the 16x from both sides. So it'll be negative 16x here, and then subtract 20, and it'll be negative 20 over there. So then it's equal to 0. Now it's a cubic, and that can be a rather challenging one to solve. But in this case, and this is generally the way one of the first things you look at when you've got four terms. In other words, we got an x cubed term, an x squared term, an x term, and then a constant term. All right. So then if we break it in half, all right, break it in half, and then this is called factoring by grouping, by the way. And then take the greatest common factor out of these two. Well, in this case, there's no common number, but the greatest common variable factor is x squared. So it's x squared times 4x plus 5. So that's factored greatest common factor on those times. And with factoring by grouping, always on the third term, bring down that sign, negative, and then we look for the common factor here, greatest common factor. In this case, it's just 4. So we have negative 4 right there. And then negative 4 into 16x gives us 4x. Negative 4 into negative 20 gives us plus 5. Those two match. And the reason why we can do this is that A times B plus A times C is equal to A times B plus C. Okay, so instead of writing the A twice, we distribute it or undistribute it, let's say, and bring it out in front as a factor. So this one being written twice gets written once times the x squared, because this x squared is multiplying the 4x plus 5. And then negative 4 is also multiplying it again. So this is an equivalent. Okay, that's an equivalent expression to the one here on that second line. And then we're just going to set each one of those equal to 0. When we set 4x plus 5 is equal to 0, subtract 5, we get 4x is equal to negative 5, divide by 4, and that gives us the first solution of negative 4/5. On the other side, you could either solve it by the square root principle, or you could also factor this as x minus 2 times x plus 2. Either way will work. The way I showed you right there technically is the square root property, but they both get you to the same place. So here's your solutions. Okay, so we got 2, negative 2, and 5/4. And just kind of remember this, the highest power here, that lets us know how many solutions to look for. Now, it is possible that 2 of the solutions could have been exactly the same, but this would tell you more or less how many to look for. You'll never find any more solutions than the highest power of or what's called the degree of the polynomial. When you have the highest degree of the polynomial, that right there is called a polynomial of degree 3. So that's why we're looking for 3 solutions. Does that help on that one?
Yes. Actually, I'm sorry, I was mistaken. Can we go over the third problem? I forgot the first problem is the like helpful page.
Oh yeah, let's see. I don't know if I got that one.
That one.
Okay, that's I may have that one on here too. Okay. Yeah, this one is kind of a pain in the neck. In Math 097, they wouldn't give you one that's got 2 square roots in it, because generally speaking, what you got to do here is you got to take it and isolate and square, and when you square, then it undoes what's inside of there. Okay, so what we're doing is subtracting the negative 2x. In other words, let's see if I can do this. Oops. So it was plus square root of 2 minus x is equal to 4. If you square it as it is, like this, and that, well, you get 16 on the right, but you're going to have a whole jumbled up mess on the left. So the best advice is just to subtract this one. Okay. In other words, you're going to have so it's going to go over here, and then you're left with 4 minus the square root of 2 minus x. All right. Now, the square root of x plus 6 is sitting by itself. All right. So when we square that, the radical goes away because the square root, basically it works like this. Because what we're saying is that we're squaring the x in there, and the square root of a perfect square is just going to make it pop out. And that'll happen with any power, but in this case, it's square root. So this one just pops out right here. On this one, all right, you just basically, you can do it one of two ways. You can FOIL it out, but whenever you square a function, I'm sorry, a binomial, which is what this is. So you could just go ahead and do the FOIL like this. It's going to be a little bit longer, but it'll work. But let me just show you, like for example, on this was another problem. If we just have x plus 2 squared, then there's a pattern to it. Okay. Anytime you square a binomial, the first one's going to be that squared. The last one is going to be 2 squared, which is 4. Take this sign and put it right here in the middle term, and you multiply 2 times x, which is 2x, times that 2, which gives us 4x. And then I should have put a plus here because anything squared. So that's what I did here. All right, so the 4 squared is 16. On this right here, it's just squared. The 2 minus x all squared just pops out as 2 minus x. The 4 squared is 16. And in the middle, again, it's 4 times this times 2, which is where the 8 comes from. All right, the negative 8. Bring that sign. So it's negative 8 times square root of 2 minus x. All right, so then we combine some like terms here. 16 plus 2 is 18. All right, now what I'm trying to do is I'm going to isolate this radical by itself and then put everything else on the other side so it's not such a big pain in the neck to square it, because we're going to have to square it again to get rid of this. So once we get the 18, we subtract 18 on both sides. So here it's gone. And we subtract the, or I'm sorry, we had a negative x, so we subtract the x, and it's gone. And over here, it's just going to be 2x, and the 6 minus the 18 is minus 12. And then we're left with negative 8 times the square root of 2 minus x. So again, we're going to square, now that we've got this one, square root by itself. Now, one thing you could do, if you wanted to, is 2 is a common factor. You could divide everything by 2 and make it a little bit simpler, but I don't think it's going to make it that much simpler, because this is the side that's going to be in a pain in the neck. Anyway, so when you square this, you square the negative 8 to get 64. Squaring the 2 minus x square root just gives you 2 minus x, and then the negative 8 was multiplying that, so the 64 is multiplying that. Okay. Now, on this side, the same things happen that I showed you about the principle here. Okay. So 2x squared is 4x squared. Negative 12 squared is positive 44. 2 times 12 is 24. Times 2 is 48. Bring down that sign. And now it's just a matter of distributing over here on the right. The 128 times 64 gives, I'm sorry, the 64 times 2 gives you 128, and 64 times negative x gives you negative 64. Then you collect the like terms, subtract 128, and add 64x. And when you do that, you get 4x squared plus 16x plus 16. And here you can, it'll really save you some trouble if you pull out the 4, because 4 is a common factor of all of those. And then there's a real easy one there to solve. Now, what you could do is you could put it in the quadratic formula, or you could factor it. This is what I did here, because that's just x squared plus 4x plus 4 squared. So then setting both of these, let me erase this. This was just fill-in work, but any way you do it, you're going to end up with one solution of x is equal to negative 2. And what that means is, okay, so we got this right here just means x plus 2 times x plus 2 is equal to 0. Either way you do it, x plus 2 is equal to 0, which means x is equal to negative 2. If you do it with the other one, you're going to get the same solution. So in this case, there's only one solution. Now you could have also, if you wanted to, if you didn't recognize that you could factor it there, you could put it into the quadratic formula, which always works. See, that's A, B, and C. So we could go negative 16 plus or minus the square root of 16 squared minus 4 times 4 times 16. And you know what that's going to give us? Oh, and it's over 2a. So what that ends up giving us is it gives us inside, it gives us negative 16. And this right here is just 0. Because that's going to be 16 squared. And that's really just 4 times 4 is 16 times 16. So it's going to come out to be 0. So you only got one solution because there's nothing to plus or minus. So negative 16 over 8 gives you that same solution of negative 2. So however you did it, you're going to come out with a solution of negative 2. And it's always wise to put it back in here and check it. But because if you put negative 2 in there, you're going to have 4 there. Square root of 4 is 2. Over here, you got negative 2. I'm sorry, 2 minus a minus 2, so that's going to be 4. So then square root of 4 is 2. 4 minus 2 is 2. So it does work. We did check it. But it's always a good idea on these to check it because it is possible to lose solutions. Does that help better? I mean, it's a tough problem because it's long.
It definitely helps. Thank you.
Okay.
Yeah, I don't remember getting any examples like that when we were going over this, where you had two radicals, on the same side with I don't know, it's an unusual one. I don't remember getting in like that.
Well, okay, this is the thing, all right. In Math 097, which is considered the prerequisite, we do it with one radical, all right? So in here, we did it with 2. Now, you may be right. Let's see, what section was that? I'll have to look. We're not going to have enough time to go through, but I mean, I can look and see. But where would that have been at? I'll check into it if I find that there was a problem with it. That it wasn't there weren't any in homework like that. I'll be glad to make an adjustment on on the exam. Okay, but I'll have to look into it. I don't have enough time to do it now. Just kind of remind me if it seems like I forget. I just want to get us past this midterm thing because this has been hanging over our heads for so long because of all that time off with Ida. It's just like we were never going to get to this point. All right. Anybody got any questions? If you uploaded your thing on there, I'll grade it. Some of them are already there, and I already gave you credit. But make sure and put those in there before, because time's gonna run out. I think it's at 10:30. So make sure and put it in there. Again, it's not a major grade. It's just one part of the homework. But I wanted to give you all some practice work to do to try to get some feedback. All right, so I'll see you Thursday. If you got any questions, let me know as soon as you can. All right, because this thing's going to turn into a pumpkin. And when is it? Is it tomorrow or is it tonight?
I think it's tonight.
Yeah, that sounds right. Yeah, the 19th. So we're starting fresh. So I would ask you start looking at this stuff here, the chapter, the 3.4. Um, it's essentially it's long division, but there's well, we already looked at that, but it's we're using the synthetic division that we talked about here over here to do these things. All right, and I'll see you Tuesday.